Assalamualaikum warahmatullahi wabarakatuh. Continue with our study with me, Aswad Muhammad. Today we will go through about the heat treatment of plain carbon. So we have our objective, what to find. We want to conduct the different technique of plain carbon process, and second is differentiate the technique of process.
Heat treatment. Heat treatment is a controlled heating and cooling cycles intended to adjust the microstructure and mechanical properties of material of specific purpose. There are few of heat treatment techniques which are full annealing, normalizing, quenching and tempering, spheroidizing, mar tempering, house tempering and precipitation strengthening, or known as hardening. In this experiment, we only use first three of the heat treatment techniques we will perform on the plain carbon steels. The first one is full annealing. Full annealing is a heat treatment often utilized in a low and medium carbon steels that will experience extensive plastic deformation during forming operation. The alloy is furnace cooled, that is, the heat treating furnace is turned off and both furnace and steel cooled to room temperature at the same rate, which takes several hours. The microstructure of annealing is coarse perlite that is relatively soft and ductile. The second one is normalizing. Normalizing is steels that have been plastically deformed, such as rolling, consists of grains of perlite which are irregularly shaped and relatively large, varies in size. An annealing heat treatment called normalizing is used to decrease the average grain size and produce a more uniform and desirable size distribution. Fine grind perlitic steels are tougher than coarse grain ones. Normalizing is accomplished by heating at approximately 55 to 85 degrees Celsius above the upper critical temperature. After sufficient time has been allowed for the alloy to completely transform to austenite, a procedure termed austenizing, the treatment is terminated by cooling in air. The last one is quenching and tempering. For quenching, the property of steel that is quenched and then tempered depends largely on the rate of cooling and tempering time and temperature. The optimum properties of steel that is quenched and then tempered can be produced only if the specimen is converted to high content of martensite during quenching. The formation of any perlite and bainite will result in combination of mechanical properties. It is impossible to cool the specimen at uniform rate during quenching, as the surface will always cool rapidly at its interior. The three most common quenching media are water, oil and air. Quenching is water produces the most severe quench, followed by oil, which are more effective than air. And the last one for tempering. Tempering is accomplished by heating a martensitic steel to below the eutectoid temperature for a specified time period. Normally, tempering is carried out at temperature between 250 degrees and 650 degrees Celsius.
For experimental procedure, first we cut the specimen provided with size less than 1 cm. Second, mark the specimen 1 until 6. The third one, heat specimen number 1 to 5 in a furnace at 900 degrees C for 30 minutes. After 30 minutes, we remove sample 2 from the furnace and cool it into air on the brick. Remove sample 3, 4 and 5 and quickly drop them into water for 5 minutes. After that, heat again specimen 4 and 5 and heat specimen 4 to 200 degrees Celsius, allow to this temperature for 15 minutes. But heat specimen 5 to 600 degrees C and allow this to this temperature for 15 minutes. Turn off the furnace, remaining specimen 1 inside the furnace. Allow specimen 1 to cool into room temperature. Lastly, keep all specimen for the sample preparation and metallography experiment.
As we can see from the result of this experiment, carbon steel can have a wide range of properties depending on its heat treatment state. Annealing reform the grain structure and produce the soft and moist ductile material. Quenching involves quickly cooling a material to form martensite, which is an extremely strong but brittle phase of steel. Tempering gives enough energy for the carbon atom to diffuse, which decrease the strength but increase the ductility, while normalizing reduce the rate of carbon that may be experienced by a metallic surface and also increase the strength and hardness of steel.
B. Why the specimen must be allowed for a few minutes at certain temperature as mentioned in the experiment procedure C? To homogenize the specimen so that the internal structure can be obtained by having enough time to get properly homogenized. C. Why all specimens are heated to 90 degrees Celsius before proceed to the next step? All specimens are heated to 90 degrees Celsius before proceed to the next step because the temperature of 90 degrees Celsius above the temperature at which austenite begin to form. Therefore, the plain carbon steel can be transformed to austenite before proceed to the following heat treatment. D. What is the special tempering process to produce bayonet? Explain the step of this heat treatment and give the advantage of this process. The special tempering process to produce bayonet is house tempering, as it is a hardening process as well as known as isothermal quenching. In this process, the prepared specimen is heated for 30 minutes above the upper critical temperature at about 875 degrees Celsius, where the structure consists entirely of austenite. It is when suddenly cooled by quenching it in a salt bath and maintained at the temperature of about 250 degrees Celsius until 525 degrees Celsius. The advantage of this process are a bayonet structure of a high strength with a significant ductility and a good wear resistance, as well as higher impact resistance and less distortion can be used. E. What is the difference in the properties and microstructure of specimen number 3 and number 4 after heat treatment? The difference in the properties for specimen number 3 and number 4 is the specimen number 4 has a reduced thermal stress compared to the normal quench, which is a heat treatment process for specimen number 3. This is prevent cracking and minimize distortion of martensite produced by tempering. Also, specimen number 3 has a lower residual stress compared to specimen number 4. Next, both specimen 3 and number 4 have the same microstructure as both of them are also martensite.
We have 6 samples. We differentiate the technique. We know the technique of the process which is annealing, normalizing, quenching and tempering. So we know what is the process of the technique.